Okay, let's play around. We're not even going to find any derivatives here. I just want to look at some composite functions, functions inside other functions, and write them, expressly write them out as one guy inside another guy. And the way you always want to think of it is your grouping symbols determine who the inside guy is. It's usually easiest to find the inside guy first. So I've got h of x as the square root of x squared plus 5x. I want to write him, just for practice, we're not even taking derivatives, as f of g of x. So who's my inside guy here? Whatever's under your grouping symbols. The inside guy here would be x squared plus 5x. And then f would be the outside. What are you doing to that? I'm taking the square root of it. Now, this is where people get confused. They're like, oh, it's not square root of x, but I have to write the outside as a function of x. Remember, really, I could say here f of input is square root of input. That's what the function really is. Anytime we're writing x, we're just being lazy. All of these functions always mean h of input is square root of input squared plus 5 input. X is just a placeholder. So the inside guy here would be x squared plus 5x, and the outside would be take your input and take the square root of it. Then I hope you can see that h is in fact f of g of x. Not f times g of x. Nothing is multiplied here. That's f of g of x. For a guy like this, a bunch of different ways you could write this. You could say g of x is just the x minus 3. And then f, what am I doing to that? I'm doing 1 over my input to the 5th power. Then h is f of g of x. A lot of times when people have trouble with calculus, it's because they don't understand function notation. If you're horribly lost right now, you got to get help with function notation. Make an office hour appointment with me. Be happy to help. Okay, let's look at these guys. I've got h of x as cosine of 3x plus 1. Who's my inside? Who's in the parentheses? The inside is 3x plus 1. And what am I doing to that? I'm taking the cosine of it. Okay. Let's write some stuff out here just so I can try to maybe clear up some of the confusion with function notation. Let's say I've got this f. Think about that guy. What if I wanted f of 3? What does that mean? That means replace the x with the 3 in parentheses. What if I wanted f of 9? That means rewrite this function, but now instead of writing x, write 9 in parentheses. What if I wanted f of triangle? Then that would mean rewrite this function, but instead of writing x, write triangle in parentheses. So if I wanted f of g of x, that would mean cosine of g of x. Well, what is g of x? It's 3x plus 1. So if I decompose this into an inside and an outside, this is the inside. That's what I'm doing to it. Similarly here. Now, I don't have any grouping symbols here. I don't have any parentheses, but I still have something that's grouped. Let's make this guy even more interesting. What if this was plus 2x plus 9? I've got e raised to a bunch of junk. So e is being raised to all of this. This is all grouped, even if I don't have parentheses here. This is all up in the exponent. Then that's my inside function. That's all up here. And what am I doing to that? I'm making all of that stuff a power of e. So again, just for clarity, I'm done. I've written them. I've now decomposed the function into an inside and an outside. I want you to see that I did it right by looking at this guy. I claim that h of x is this. Well, what would that be? F of g of x means rewrite this, rewrite the outside guy, but now instead of writing x, write whatever is written inside here. G of x in this case. What is g of x? It's all that stuff. We're not taking the derivative of any of these guys yet. We're just practicing decomposing a function as a composition.